I'd like to move now to the next submission, which is an oral presentation from Dr. Ulsh, if I pronounce it right.
Yes.
As outlined in CMD 15H 2.120. Dr. Ulsh, the floor is yours.
Thank you, President Bender. Good afternoon. My name is Brant Ulsh, and I would first like to thank the commissioners and especially the participant funding program for allowing me to participate in this important hearing. I will make every effort to do as good a job at speaking deliberately as the previous speaker did. I'm somewhat challenged in that regard, being an American, but I hope that you will overlook that handicap. Also, the agreement that I signed with the participant funding program made it very clear that I should speak in terms that the public would find understandable. Again, I'm challenged in that regard, being a scientist, but I'll do my best. I too bring a different perspective from what you've heard up to this point, perhaps. I am a certified health physicist, and I am active in the International Radiation Protection Association. I'm also a president-elect of the Health Physics Society's Environmental and Radon Committee. However, I do need to make it clear that I'm here as a member of the public, not as a representative of those organizations. So the opinions that I express are my own. I also hold a PhD in radiological health sciences, and from 2001 through 2003, I was a postdoctoral fellow at the McMaster Institute of Applied Radiation Sciences in Hamilton. So I tell you that just so you can evaluate my qualifications to give you a somewhat informed opinion today. The focus of my research while I was at McMaster and in the 10 years since has been the effects of low doses of radiation, both on humans and on non-human species that are exposed in the environment. My remarks will specifically focus on some research that I collaborated on recently that looked at the effects of low concentrations of tritium on fish. I know that that's a topic of great interest to the public. I will also conclude with some personal observations that I offer as a somewhat distant neighbor from the South. So for the benefit of the public, I know that a lot of certainly the commissioners and the CNSC understand this, but just a brief few words on tritium. It's a radioactive form of hydrogen that emits a very weak radiation when it decays. It's a natural part of the environment, and it's produced in the atmosphere by natural processes. It's also produced in can-do reactors like Bruce. And in the environment, tritium is found mostly in the form of water. So anywhere that water goes, tritium goes. And because it's radioactive, governments around the world have established limits on how much tritium is allowed to be in drinking water with the goal of protecting human health. Internationally, these limits range from a high of about 76,000 becquerels per liter in Australia to 7,000 becquerels per liter here in Canada to 740 becquerels per liter where I'm from in the US. And according to the latest environmental monitoring data available, tritium emissions from Bruce result in a maximum public dose of 0.0004 millisieverts per year. And to put this into perspective, this is about 2,500 times lower than the public dose limit in Canada, and it's about 250,000 times less than the lowest dose that we know can cause negative public health effects. So from a human health perspective, the tritium from Bruce at the levels that it is currently emitted simply do not pose a human health hazard. But what about non-human organisms like fish, upon which the public and especially Aboriginal people depend? Is the tritium from Bruce causing any negative impacts in these species? And we heard a very interesting presentation this morning about the whitefish research that's being conducted. I listened very attentively to that. But answering this question was the goal of the research project that I mentioned earlier that I've been involved with recently. And over the past couple of years, I've had the privilege of collaborating with researchers from the Canadian Nuclear Laboratory to investigate the effects of very low concentrations of tritium on fish species. We exposed fish cells to concentrations of tritium ranging from natural background on the low end, and the concentrations that one finds in the waters near the Bruce power plant. That formed the low end of the range that we looked at. And on the high end, we looked at concentrations that were somewhat higher than the Australian standard. And our goal here was to look at the adequacy of international drinking water standards for tritium. We performed 8 distinct tests of biological effects. Due to time constraints, I won't go through all of the intimate details of those tests. But our approach was similar to that that's taken by a doctor when he orders a panel of blood tests for a patient. Each test is designed to tell the doctor a piece of information related to the patient's health. And by analogy, each of the 8 biological tests that we performed were designed to give us a more complete picture of the health of the cells that we were exposing to tritium. These tests were designed to be very, very sensitive to detect effects at the cellular level, which typically occur at far lower concentrations than you would begin to see effects in whole organisms or in populations of organisms. For each test, we compared the effects of cells that were exposed to varying concentrations of tritium to the effects that we saw in control cells that were only exposed to natural background. So what did we find? Well, as expected, we found that tritium does indeed cause breaks in the fish DNA. And this agrees with decades of research on biological effects of radiation, and it would have been quite surprising if we saw any other result. Now, this might seem like a cause for alarm, but it's important to remember that even normal activities, as mundane as breathing oxygen, cause thousands of DNA double-strand breaks in the cells in our body. And this is a completely normal occurrence, and cells have evolved defense mechanisms to deal with this damage. If they didn't, they wouldn't be here. The question is, did this DNA damage have any negative health consequences for the cells? Well, the answer is no. And if anything, we saw just the opposite. We found that tritium concentrations up to 100 times higher than the concentrations observed in fish near Bruce actually somewhat protected fish cells from dying. And we also found clear evidence that the cells were responding to tritium exposure by using energy, but it was less clear what the cells were using that energy to accomplish. Of course, you can't really ask them. Our results did not show that the cells were repairing the DNA damage, and we saw no evidence that tritium concentrations, even 10,000 times higher than those in fish near Bruce, had any negative effects on the cell's abilities to reproduce. So taken together, the results of our research show that, as expected, tritium causes breaks in fish DNA, but this tritium exposure appears to protect the cells from dying, and it does not appear to be having any negative effects on the cell's ability to reproduce. Our results are consistent with a large body of radioecology research that spans decades, and I believe that it shows that the levels of tritium in the water and in the fish near Bruce is far below those that cause negative effects in fish. So now for some personal observations. I currently live in Cincinnati, Ohio. So like I said, you can consider me a distant relative or a distant neighbor from the south. And I also come today not only because I have a professional interest, but I have 2 children, one of whom was born at the McMaster Medical Center. So he has dual citizenship. He's a Canadian citizen, and I'm a frequent visitor here. Well, unfortunately, the American Lung Association has ranked the area where I live in Cincinnati as having the 8th worst air quality in the United States. And there are a lot of factors that contribute to that, but one very significant contributor is the line of coal plants up and down the Ohio River where I live. And in fact, I live just minutes from the Zimmer power plant. And the history of that plant, I think, provides some interesting lessons for your deliberations here today. The Zimmer plant was originally scheduled to be a nuclear plant, but in 1982, pressure was brought to bear on the regulator in the U.S., the U.S. Nuclear Regulatory Commission, to order a halt to construction, and very shortly after that, the decision was made to convert Zimmer to a coal plant. As a result of that decision, every day, my family and I breathe air that's polluted with benzene, toluene, dioxins, lead, mercury, and 79 other nasty compounds. So what should we do? How can my family and our neighbors have both a safe and reliable supply of electricity and clean air? Well, we don't have to look far to find the solution. We just have to look north. According to the Ontario Ministry of the Environment, air quality in this province has significantly improved over the past 10 years, with decreases in several pollutants. How did you all do it here in Ontario? Well, by phasing out coal plants and replacing that electricity by bringing the laid-up Bruce reactors back online. Ontario's nuclear power plants now supply about 60% of the electricity used in the province, and coal supplies 0%. By contrast, 67% of Ohio's electricity is supplied by coal and 12% by nuclear. Ontario has clean air and Ohio has polluted air. It's really that simple. Every time nuclear plants have been prematurely shut down, air pollution has increased. It's happened in Germany, it's happened in Japan, California, Wisconsin, Vermont, Maine, and I might add that at least those locations in the States where that has happened, it has been economically devastating for the communities that it affected. Following a similar course would be snatching defeat from the jaws of victory. And I respectfully support the CNSC staff's decision to recommend a renewal of Bruce's operating license for the sake of public health and a clean environment in Ontario. And I would be happy to take any questions the commissioners might like to ask.
Thank you.